So today I will be demonstrating how to find the specific heat. So given an example where you are given the mass of iron to be 24.3 grams, and that would be heated to 100 degrees Celsius, the volume of water 30 millimeters at 22 degrees Celsius, and the maximum temperature of both the iron and the water would be 28.3 degrees Celsius, and you're asked to determine the specific heat of iron. So in this example, a few equations that we're going to be needing is the specific heat equation, which is heat in joules divided by mass and the delta temperature in Celsius. You're going to need the heat of the system, which equals the negative heat of surroundings, and you're going to need the equation to find delta temperature, which is the final temperature minus the initial temperature, and then you're going to need a rearranged version of this specific heat equation, which is to find the heat in joules, and to find that you're just going to multiply specific heat times the mass times delta temperature. So to get started, the first thing that we're going to want to do is we want to find the mass of water, and that's in grams. So to do that, we know we have our density equation, which is mass divided by volume, but because we have our volume, we're going to rearrange our equation to be density times volume, which equals mass. So we have our density of water, which we know is 1 grams divided by milliliters, and we're just going to multiply by our volume of water, which is given, which is 30 millimeters. And we know that to be, that's just 30 grams. The next thing we're going to do is that we're going to now take those 30 grams and we're going to plug it into our equation for heat in joules. So to do that, we're going to need our specific heat of water, which is 4.184, and that's in the joules divided by grams in degrees Celsius. And then we're going to multiply that our mass, which is 30 grams of water, multiplied by our delta temperature. Now to find delta temperature, we're going to need our initial temperature of water, which is very important. Not of the iron, but of water, which is 22. So we're going to need our initial temperature, and then we're also going to need our final temperature. So we're going to put that in front, our final temperature in front, and then we're going to subtract that, and that is going to be 6.3 degrees Celsius. So then we're going to plug that in, 6.3 degrees Celsius, and then when we multiply that, you plug it into the calculator, it is 790 degrees. 790 joules. So now that we've found our heat of water, now we're going to plug that in. Remember, that's not our goal. Our heat is by the specific heat of iron. So we're going to plug that in, this right here. We're going to plug it into our heat equation, which is the heat of the system equals the opposite, negative the heat of our surroundings. Now, the system is iron and our surroundings is water, so we're going to plug that in for water. So 790 joules is negative 790 joules is our heat of iron. Now we're going to plug in this, what we got here, negative 790 joules, to our specific heat equation to calculate the specific heat. And that's going to be, so we just plug in 790 divided by the mass, which is 30, not 30 grams because that's the mass of water, but we're going to calculate the mass of iron, which is 24.3 grams, and we're going to multiply that by, and the delta of temperature for the iron, 28.3 degrees Celsius minus 100, that's going to give us a negative value, it's negative 71.7 degrees Celsius, and then we're going to put that in here, Celsius, and then that is going to give us a final result of 0.45 joules divided by grams Celsius, and that is the specific heat of iron.